Electricity is an invisible force of nature, powering our world and lighting up our lives. Lightning in a thunderstorm is a spectacular display of electricity's raw power. This brilliant flash is pure electricity, nature's own light show, both beautiful and dangerous. Incredibly, a bolt of lightning is hotter than the surface of the sun. Electricity is all around us, lighting up cities and connecting our world. Today we will delve into the fascinating topic of electricity. To understand electricity, we need to journey into the microscopic world. Think tiny atoms. These are the fundamental building blocks of everything around us. Atoms are like mini solar systems, each with its own central core and orbiting components. They're complex structures constantly in motion. At the heart of each atom lies a nucleus, a dense core made up of protons, which carry a positive charge, and neutrons, which are neutral, meaning they have no charge. These particles determine the atom's identity and mass. Surrounding the nucleus are electrons, tiny particles with a negative charge, whizzing around in specific orbits or shells. Normally, atoms are balanced. They exist in a state of equilibrium. This balance means they have an equal number of protons and electrons, resulting in a neutral charge overall. But electrons on the outermost edge, the valence electrons, are the key players in electrical phenomena. These outer electrons can jump away with a little push, a bit of energy from an external source. When an atom loses or gains an electron, it becomes charged, transforming into what we call an ion. This movement of electrons, this flow of charged particles, is precisely what we know as electricity. Imagine a tube filled with marbles, a simple analogy to help visualize this electron flow. When you push one marble in, another one pops out the other end almost instantaneously. Similarly, electrons don't actually travel the whole distance through a wire. Instead, they push each other along, transferring energy quickly from one electron to the next. This chain reaction, this domino effect of electron movement, is what constitutes an electric current. It's this intricate dance of electrons that powers everything from our phones to our homes. So, in essence, electricity is just the flow of these incredibly tiny negatively charged particles. And that's the fundamental secret behind every light switch, every electronic device, and the entire world of electrical engineering. Electrons need a path, a circuit to flow. A circuit is a closed-loop power source, device, and back again. Metals like copper are great conductors, letting electrons move easily. That's why wires are copper wrapped in plastic for safety. Plastic and rubber are insulators, they keep electricity where it belongs. A simple circuit connects a battery to a bulb with wires, and the bulb lights up. The loop must be complete for electrons to flow. Insulation prevents shocks and short circuits. Circuits control where electricity goes, making it useful and safe. Every device you use relies on these simple paths. That's how we harness electricity. Electricity isn't just for gadgets and gizmos that light up our homes. Nature uses it too, in ways that might shock you. Electric eels, for example, can zap their prey with a surprising jolt. They unleash up to 600 volts, enough to stun or even kill. This incredible power comes from special cells acting like tiny biological batteries, all working together. Humans, fascinated by this force, have studied electricity for centuries, trying to unlock its secrets. Benjamin Franklin's famous kite experiment bravely and perhaps recklessly proved that lightning is indeed a form of electricity. But remember, don't try that at home. Safety first when dealing with such powerful forces. Then, Alessandro Volta revolutionized our understanding when he invented the first battery, a groundbreaking achievement, truly sparking the electric age and paving the way for countless innovations. Electricity doesn't just power our world, it saves lives. Defibrillators, for instance, use carefully controlled electric shocks to restart hearts that have stopped beating. And incredibly, your own body runs on electricity, a complex network of bioelectrical signals. Nerves constantly send signals throughout your body with tiny, rapid electric pulses. Every thought you have, every movement you make, and every heartbeat is powered by these intricate electrical signals. Our brains and nerves are like incredibly sophisticated biological circuits, constantly processing and transmitting information. Electricity connects us to the world, powers our technology, and most importantly, keeps us alive and functioning. From the shocking abilities of electric eels to the complex bioelectricity within humans, it's a fundamental force of both nature and scientific exploration, constantly revealing new wonders. So, next time you flip a switch, remember you're more electric than you think. Imagine life without electricity, no lights, no phones, no internet. It powers everything: your home, your school, your hospital. Refrigerators, microwaves, computers, all run on electric current. Our world depends on a steady flow of electrons. Electricity is key to a cleaner future too. Wind turbines and solar panels turn nature's power into electricity. Electric cars are replacing petrol engines, helping the planet. Our society runs on this invisible energy. From the tiniest spark in your brain to massive power grids, electricity shapes our lives. Understanding it helps us appreciate its magic. Next time you flip a switch, remember the journey of those electrons. Electricity is the lifeblood of modern life. Science is everywhere.